This video covers section 9.9, the complex number system, objective 3, multiply complex numbers. To multiply complex numbers, we follow the same process that we did for polynomials and distribute 3x to 2x, which is 6x squared, 3x to the negative 9, which is negative 27x. We also apply FOIL when we have binomials, 16x squared plus 12x minus 12x, which is 0, and minus 9. We do the same thing with complex numbers. We take 8i times 4 minus 9i, and we distribute it across and get 32i minus 72i times I is I squared. And here's where things get different. We need to remember that this section was started by saying I squared is negative 1. So we get 32i minus 72 times negative 1. And that changes that to a plus 72. And style-wise, we always like to write it as a plus bi. So we say the real part 72 and the imaginary part is 32. So the only new thing here is that I squared is negative 1. So when you FOIL it out, 5 times 4 is 20. 5 times 9i is 45i. Negative 2i times 4 is negative 8i. And negative 2i times 9i is negative 18i squared. The negative 18i squared is negative 18 times negative 1, which becomes plus 18. (20 plus 18 is 38, and 45 minus 8 is 37. So the real part's 38, imaginary part's 37. And this leads us to 3 practice problems for you to try. I encourage you to press pause on your video and work these out, and come back when you're ready to see the solution. Now that you've had a chance to work these out, I'll work these out with you. We distribute the 3i to the 5 and get 15i. The 3i to the negative 4i and get negative 12i squared. Negative 12i squared is positive 12 because the I squared is negative 1. And we have 12 plus 15i. Letter B, we FOIL. Negative 2 times 4 is negative 8. Negative 2 times negative 2i is positive 4i. 5i times 4 is 20i. And 5i times negative 2i is negative 10i squared. The negative 10i squared is going to become a plus 10. 4i and 20i is 24i. So we have negative 8 plus 10, which is 2 plus 24i. Letter C, negative 2 plus 5i times negative 2 minus 5i. Negative 2 times negative 2 is positive 4. Negative 2 times negative 5i is 10i. 5i times negative 2 is negative 10i. And 5i times negative 5i is negative 25i squared. The 10i minus the 10i, they cancel out. And the negative 25i squared is plus 25 because the I squared is negative 1. And that gives us 29. So this is the segue into the next idea, which says that anytime you take two terms and change the middle plus to a minus, they're called complex conjugates. And it's such a nice result because there's no more i's left over. So the complex conjugate of a plus bi is a minus bi. So if you have 4 plus 7i, its complex conjugate is 4 minus 7i. If you have negative 10 minus 3i, you change the minus sign to a plus, and you've got the complex conjugate. We saw in this practice 4c that when you multiply a complex number by its conjugate, it's said to be free of radicals, since we know that I is equal to the square root of negative 1. It's free of i's. And so when you do these kinds of things, negative 2 times negative 2 is positive 4. Negative 2 times negative 5i is positive 10i. And this is negative 10i. Those things cancel out, and you're left with minus 25i squared, which is 4 plus 25. So what we really say is a plus bi times a minus bi is the same thing as just squaring the two terms, a squared plus b squared. So this was negative 2 plus 5 squared. Negative 2 squared plus 5 squared, which is 29. So you can just say these things are equal to a squared plus b squared. 9 plus 16 is 25. A squared plus b squared. 49 plus 100 is 149. So compare this with x minus 3 times x plus 3, no complex number. This gives us x squared plus 3x minus 3x minus 9, which we called this the difference of two squares. This one is x squared plus 3xi minus 3xi minus 9i squared. And that's a plus 9, so this gives us the sum of two squares, the sum of two squares. In 9.4, we used the following property. The nth root of a times the nth root of b equals the nth root of ab. This property only applies to real numbers. If the radicand is negative, we first write the radical as a complex number. Some people come along and say this is equal to the square root of negative 25 times negative 4, which is the square root of 100, which is 10. This doesn't work because square root of negative 25 is 5i, and the square root of negative 4 is 2i, which gives us 10i squared, and I squared is negative 1. So this gives us negative 10, not 10. So again, this rule of being able to put them underneath the same radical only applies if they're real numbers. So before we multiply, we must convert these into our imaginary numbers. First 5i and 2i, and then FOIL. 2 times 1 is 2, minus 2 times 2i is 4i, plus 5i, minus 10. I times I is I squared. Minus 10i squared is plus 10. So that gives us 2 plus 10 is 12. Negative 4i plus 5i is I. 12 plus I. And here are two practice problems for you to try. I encourage you to press pause on your video and work these out, and come back when you're ready to see the solution. Now that you've had a chance to work these out, I'll work these out with you. First, convert these to complex numbers. Imaginary numbers, square root of negative 9 is 3i. Square root of negative 36 is 6i. When you multiply those together, you get 18i squared, or negative 18. Letter B, square root of negative 36 is 6i, so I have 2 plus 6i times 4 minus square root of negative 4 is 2i. Foiling that out, we get 8 minus 4i plus 24i minus 12i squared. Minus 12i squared is plus 12, so 8 plus 12 is 20. And negative 4i plus 24i is 20i. 20 plus 20i. And this concludes the video for section 9.9, the complex number system, objective 3, multiply complex numbers.